He is the co-founder of Solana, Anatoly Yakovenko. Totally welcome to the show.
Thanks for having me. 19 out of 20 things fail. If you have like a 5% hit rate, you're an awesome like product developer. You need a CEO that wants to do all those things to make this thing successful. I'm not that person. What I want to do is code.
Welcome to the Coinbase Developer Podcast, a technical deep dive with top on-chain builders in crypto and beyond. I'm Yuga, Cohler, engineering lead at Coinbase Developer Platform. So Coinbase often gets a rep that it's too Ethereum focused, but the reality is that Coinbase Developer Platform, CDP, is absolutely and unequivocally multi-chain. People should know that a lot of what we're building extends well beyond the Ethereum ecosystem. Our server wallets, for instance, our embedded wallets both support Solana with advanced capabilities like sponsor transactions. And the X402 protocol, which we'll talk about, is shipping Solana support right now. So today's guest really needs no introduction on the topic of Solana. He is the co-founder of Solana, Anatoly Yakovenko. Totally welcome to the show.
Thanks for having me.
So, your lore is pretty legendary on crypto Twitter and the ecosystem in general. But even before you came to crypto, you were a hardcore engineer. You're still a hardcore engineer. In particular, you spent 13 years at Qualcomm, which is a company that doesn't get talked about that much today. That's involved in wireless technology. More recently, they've gotten involved in semiconductors as well. But tell us a little bit about your career there as an engineer, as an IC, what code you were shipping, and like what skills you built there.
You've definitely used something that I worked on, which is kind of like, I think the cool part working at a company like that is that a lot of people are just not aware of what it does. And it was kind of ironically primarily focused on almost protocol development. So it's a fabless semiconductor company, which was kind of a big deal in the late 90s, like NVIDIA. And they developed a protocol for wireless communication that was more efficient and could support higher data rates than what was available at the time. The challenge that they were facing is that to support these higher rates, they had to do more computation locally on the phone and the tower. And this is what people thought was going to be impossible. And people underestimated how fast semiconductors move and improve in terms of both power and efficiency. And they built CDMA, and it was clearly a better approach to GSM networks, the fight with European standards and yada, yada, yada. And eventually we get to 5G, which still to this day borrows heavily from those kind of early CDMA ideas. Interesting note, CDMA was actually first theorized by an actress during World War II, Hedley Lamar, I think, for communication with like missiles.
That's interesting.
That were really hard to jam because of this frequency hopping aspect of it.
Super interesting. So, I mean, you've been pretty close to the metal in terms of like the stuff you've been working on. And, CDMA is this technology that sort of splits a single channel across multiple bands so that they can be used across. Tell us a little bit about like another thing I want to point out is like probably the regulator you were dealing with at Qualcomm for technology like that is like the FCC.
Yeah.
Right. And now you're dealing with different regulators like the CFTC and the
Also
SEC.
FCC, shipping
Oh,
seeker.
of course. Yeah. See, Saga, absolutely.
Yeah.
But like when you were working at Qualcomm, like were you kind of thinking about the like technology at like a higher level as you obviously do now, or were you kind of just like working on a specific part of it and kind of shipping code just focused on one specific thing?
Yeah, I was shipping code, and most of the time, and I think it's just kind of part of the way that the products that Qualcomm ships is you're working on performance improvements and latency specifically. Like one of the first projects I worked on was this kind of push to talk thing. I don't know if people remember Nextel walkie-talkie over cell phones, but we had a demo where we could push to chirp, is what they called, between San Diego and like Hyderabad, India, in sub 80 milliseconds. This was like 2004. So gluing together all of these services and lanes and stuff and analyzing at a protocol where you're getting latency, where messages go in and take too long and stuff like this, and can you do it at scale, and reducing those was just always something that I just worked on from day one in my career. And even, I had this kind of worked at a cheesy voice over IP startup in college that failed. Again, there I was looking at performance optimizations and stuff. How do we actually make this stuff scale? Because a lot of times, I guess, if you're dealing with human interfaces, people really are latency sensitive. That's probably the biggest thing that makes a UX feel good or feel crappy, is like how snappy it is, how fast of a response you get.
Totally. I mean, I worked at Google for 8 years, and it was all this data around how long it takes to load the search results page, and the number of incremental
Yep.
dollars you can make on ad clicks based on millisecond load time. So it's obvious like that the influence of what a large influence that optimizing performance has played in your software engineering career. So I would assume like you're probably working on low level drivers like C++, and is that where sort of your
Yeah.
love for Rust came from?
Yeah, I worked my hatred for C++, and then love for C, and then the love for Rust came from my experience working in this low level code. And the basically, like, I think uh C is so limiting that you cannot really create code bloat because you just won't ship. The project won't work and it'll die. So you have the survivor bias of C that actually works is pretty good C, because you have to have at least people that minimize the complexity in this whole process of shipping large code bases. You just can't ship a large crappy C code base. You can ship a large crappy C++ code base, and then you're spending time debugging like these random segmentation faults, and you're just clawing your eyes out about how, how dumb of a waste of time it is. And you can ship crappy Rust code, but it won't have those problems. It'll have different set of problems, but at least you're debugging, I think, stuff that feels like you're making real progress in the product when you're doing that. And I think this is like the big benefit of Rust, is that you can ship very complicated code like you can with C++, but the compiler solves a lot of these kind of like really painful annoyances that you end up with any kind of large C++ code base, which are like seg faults and deadlocks and all of this, which you can avoid with really strict coding guidelines. But like, it's just coding guidelines are human work, and you want machine to do it. This is what the Rust compiler is great at. It's a machine for basically sane C++ coding standards.
Yeah, I mean, the last time I used GDB was probably in college, so
Yeah.
I can sympathize with that.
Yeah.
So, kind of fast forwarding to 2017, you have some sort of light bulb moment around Solana with your co-founders, who I believe also came from Qualcomm.
Yep.
And Qualcomm is about sending data high throughput through telecommunications networks. Blockchains are about sending data, especially through a decentralized network, but the two use cases are vastly different, right? One is about money and value. The other is the packets are about like voice. But was it for you like, was that distinction sort of irrelevant? Was it all just about sending data across networks?
No, actually, so there's kind of two pieces that happened, that clicked for me. One is, I think Ethereum came to the forefront in 2017, and smart contracts became like a thing. I mean, none of the stuff worked, as you remember. It was all very theoretical, but there was this new type of code that you could ship as a developer. And vast majority of my time at Qualcomm actually spent on like that, exposing silicon to developers. So I was working in SDKs and trying to write protocols between different subsystems in the chip, like how do you access the DSP and stuff like that, and expose those APIs to developers in a sane way. Um, and you actually have to deal with very similar problems. You have a very memory constrained environment. It's an embedded system, so cycles, memory, all this stuff is very expensive. And if you have a real-time OS, that means you have actually a very constrained rudimentary kernel that's driving all the programs. So not only you're constrained on resources like in memory and cycles, you're constrained on time. You have to fit your loops to run in particular set of milliseconds, that program can operate in. And that is almost the exact same problem that you have in smart contracts. We have to have deterministic execution that terminates. So all of these kind of like problems that were solved by EVM were very obvious to me as second nature. Having Ethereum come to the forefront as a smart contract platform was really what got me interested in even considering kind of the opportunity because I literally spent a career looking at virtual machines, trying to understand them inside out, and how do we fit these constraints, memory, cycles, time, and like let developers expose those in a way that doesn't blow up the system. Because again, like even if your phone isn't running financial software, you can't have malicious applications that brick everyone's phones or do denial of service and stuff like this. These become like problems that maybe cost not $10 million in a hack, but millions of dollars per day and lost customers to these big companies. So exactly the same kind of paranoia on all how to manage all those resources. The big kind of like eureka moment for me was this. It actually did happen. As the legend goes, I had two coffees and a beer in Cafe Soleil in San Francisco. That mixture didn't set well with me. I was talking to a buddy of mine who ended up joining as a co-founder, who's now the CTO of Anza, Steven, about single-threaded mining because we were literally setting up GPU systems for deep learning at Hurricane Electric, and we were mining crypto in the background to pay for those GPUs. That was our side gig
Nice.
just for fun. And we were like, why are people paying us for this? It seems like wasted cycles. What's the whole point of proof of work? And really trying to get in and understand the nuance of Nakamoto consensus. And the idea of single-threaded mining was kind of what kept ruminating in my head. And at 4 a.m., I had this kind of eureka moment. Oh, there's another physical property you can measure with cycles that's not energy. You can actually measure the passage of time and also using SHA-256. So I had the same kind of gut. I'm not a cryptographer, and every software engineer that is not a cryptographer knows enough about cryptography to be dangerous. But at a gut level, I felt that if you can measure energy in a secure way with Bitcoin, this approach would also work for time. And having a trustless source of time meant that even though I wasn't working on radio protocols at Qualcomm, but time division multiple access was the first cellular protocol that anyone's ever built. You kind of had this eureka moment. Oh, we can now take all the properties that you get from optimizing for channel efficiency in wireless. You can apply them now to blockchain. And back of the envelope, it was 1,000 times faster than Ethereum or Bitcoin.
Amazing. And that's how proof of history came about.
Yep.
And, kind of the rest is history, as they say. Now,
And now it's going away, which is great.
yeah, that's what's coming, which is amazing. Um, Now we can, obviously, Solana and Base are two of the blockchains at the forefront of the ecosystem, and there are plenty of debates to be had around the trilemma and decentralization and all this. I kind of want to ask from a slightly different angle, which is that we see, especially with the passage of the Genius Act, a lot of stablecoins are coming on chain.
Yep.
And a key question is going to be around the liquidity fragmentation of these stable coins as more and more assets on value come on chain. Where do you see the multi-chain ecosystem going? Do you see these is it going to be an M times N proliferation where each stable coin will have to have N deployments? Will it concentrate on certain networks, especially with Arc and Tempo? What's your kind of prediction around that?
I think they will look like Circle CCTP, so cross-chain transfer protocol. The thing that people need to understand is that representation of a dollar is virtual. It is just a piece of data. Um, and it is inside a Circle bank. And even that bank's representation of a dollar is virtual.
Yep.
So a lot of these inefficiencies are where these dollars are allocated versus how capital efficient it is. A lot of these things are all synthetically made. From a business perspective, like Circle, it doesn't matter where the dollars are issued, whether they're in Solana or in Base or on Ethereum layer one, because their internal ledger is a source of truth and their banking relationship and how they hold those assets, whether it's treasuries or whatever, that's their capital efficiency, how they measure it in terms of return on like ROI. So every dollar that's minted on any chain in any environment ends up with a treasury yield in Circle's database. So I think for stablecoins, it's quite simple. If there's demand, you will have stablecoins there. And what drives demand has to be ultimately driven by retail and kind of end-to-end use cases. And I think so far the biggest driver for stablecoin adoption has actually been spot markets for Bitcoin. That's kind of probably the big one. I would say 80% of current stuff, and that's at those are deposits that are going to exchanges, so on their ledgers. Um, and interestingly enough, like you've seen this, I think, with BUSD and like back in the day where there was kind of this stablecoin war with Binance. Um, once those stablecoins are deposited into Binance, they're again virtualized and synthetic, and they can convert them to their own stablecoin internally and move them off Circle's kind of ledger to their own and earn their own right ROI on it.
Yep, yep.
So where they are in the networks is going to be largely based on how much demand you can get from some real world business that depends on them. Um, Stripe is an awesome company. I'm sure they're going to do well. So is Circle. Um, so is Ethereum Layer 1. If you think of that as an ecosystem, there's a lot of demand for that. I think Solana has done as an ecosystem has done a more than I expected already. But I think it's really well positioned because there are use cases that really depend on having as many connections as you can to as many businesses in the world, and be as cheap and as fast as possible. Those are all kind of things that are important, I think, for adoption.
You said something really interesting there, which is that at the end of the day, the demand is going to be driven by essentially some end user that is using a stablecoin for some purpose, like buying spot Bitcoin.
Yep.
What are your thoughts on that? I think that's certainly true. And there's also this narrative around institutions coming on chain for, maybe internal treasury management or cross-border settlements for B2B cases. Do you not see that though as the final driver of demand?
Those are all basically there's a lot of painful work in finance of ledger reconciliation.
Yep.
Like these back-end systems with their own private databases that oftentimes have bugs. It's incredible that after all these years that these systems still have bugs. And the reason why people still run COBOL on mainframe is because those it doesn't have a bug, so don't touch it.
Yeah, yeah, yeah.
Like, so you end up with these like kind of dinosaur systems that are all a little bit flaky, and reconciliation is again also just a buggy process. You're trying to match records from one database to another one that are asynchronous, and you have to have your own notion of finality. And the way that all these systems were built is that like, well, if it's stuff that's 2 days old, it's probably not going to change, so we can reconcile up to that and call that settled. And this is like a lot of this where the stuff matters is that it's a cost to every business that's involved. And they have to have these end-to-end processes with every different business that needs to reconcile with themselves. It's just a massive headache. I think why you will see rapid adoption of blockchains, especially public ones, but maybe more corporate ones like Tempo, is that it becomes a single source of truth. If you use stable coins and you basically use that as your ledger and source of truth, you just eliminate a whole bunch of overhead. You can settle faster, so you get your money faster, you pay out faster, just your business relationships become more optimized. And to me, this is like the business email moment of the internet. Like the way that internet adoption happened was that people used email at work. They got used to what an email was, and they got used to sending links to each other. So they started understanding what the web is and this kind of weird data structure. The mental model actually slowly shifted, starting on the business side. And then you had internet native businesses that are kind of exploded that would not have been possible or conceivable as a trillion-dollar company prior to that kind of mental model shift. Like Facebook, the idea of Facebook doesn't make any sense. It's a data structure social graph that is not like valuable asset or commodity, but the fact that it exists is purely a very internet only kind of thing that wouldn't exist otherwise.
So, some would argue the value of the social graph is going down now because everything is about just an algorithmic,
Yeah.
for you page. But point taken, yeah. Like basically, I mean, it's funny. There are ledgers; they can be decentralized, they can be centralized, and sometimes you have centralized ledgers depending on decentralized ones, and vice versa. It feels a little bit like, oh, like we're kind of
I, I
recreating
think
some stuff.
I think immutability is actually really, really important because um, the speed of settlement actually depends on immutability. If you have a corporate chain that is mutable, that is under control of some set of, corporate overlords, that becomes their own database system that is going to have bugs when you reconcile because if they make a state mutation, you're like screwed. Like you're like you already settled, right? You can't rely on that system as a source of truth. So I actually think that you're not going to have too many private chains that are viable. I think vast majority of things are going to look like permissionless blockchains, honestly. And that doesn't mean they're not going to have like Stripe driving Tempo as the major driver of that permissionless environment. But all the properties that people want out of a ledger are the ones that are implemented in a fully permissionless chain that is robust against adversaries and is immutable and all of these things.
Yeah, that's fascinating. Immutability, just append only, can't change things. That's sort of where the trust derives from. So
Yep.
it makes sense. When we say finality, what we're talking about is the lack of ability to reorganize blockchain history.
Yep.
Um, so I'd be curious to hear your take. I believe the Monad airdrop was today. We're recording this on October 28th. And there are other L1s in addition to the sort of corporate change like Arc and Tempo. There are other sort of more permissionlessly branded, let's call it, L1 blockchains like Mega ETH or Monad or earlier Sui and Aptos that are online. How do you see Solana's position relative to them and like the advantages it offers versus these other blockchains?
I mean, I don't know we would have succeeded if we launched today because like I think basically what worked for Solana was that we launched in 2020. We were the first kind of next generation blockchain, and we were dramatically different compared to Ethereum. Like in terms of feeds and throughput and latency, all those things were order of magnitude better. Now you're seeing, I think, more marginal improvements that not only have to compete with each other, but also competing with Solana. And effectively, I think it's just harder to differentiate. It's harder to show a direct price improvement for a user. Like there was this Binance flash crash, and the median price on Solana per transaction went up to 7 cents. So that's like in my mind, that's too high because I'm an engineer and I'm like, okay, there's optimizations here we can do, and it'll be zero point 0.7 cents next time under the same load. But it's just that 5 minutes where the median fee was 7 cents is not enough to get a business to change chains anymore. But on Ethereum, it still went up to like 1,500, and that is definitely enough for businesses that depend on like reliable low cost to go change. Now each one of those business on the Ethereum L1 now has a ton of options. It could be Base or Solana or any one of these chains. So the ability to aggregate enough use cases under one roof, I think, is much harder because you now have these alternatives. So you can't really differentiate. Um, so I don't know like which of these environments is going to survive and kind of do well. We'll see. I think what was weird too is a lot of competitors that we were competing with were also EVM environments. And I think we would have failed if we were EVM chain. Because again, like a big part of building an ecosystem is having kind of diehard unique developers that just grind through this 4-year process of getting to product market fit. And the hurdle to build on Solana is just enough friction to where if something is catching PMF in Ethereum or somewhere else, it's just very hard to fork it and build it on
Mm.
Solana. So if you're a developer, you actually have that friction means that if you're able to overcome it and build a product, um, you're not competing with a whole bunch of forks like low effort forks.
Mm.
So we saw that being as a really good filter for founders, and that is like I think probably the biggest constraint to any ecosystem is getting enough credible founders that are gonna grind for 4 years.
That's actually a really interesting point. So the fact that, largely speaking, the EVM and SVM developer environments are kind of incompatible, right? You can't just take a Solidity contract and
Yeah.
put it on Solana, meant that it acted actually as a filter for how serious these developers were in Solana, which is very interesting. And on that topic, like, Solana has a very obviously rich ecosystem, ranging from hardware, kind of spearheaded by you, whether it's the Saga or the Seeker phones. You have Pump.Fun and the entire series of sort of meme coin related products. You also have, I think there was an announcement that Western Union was going to be using Solana today for stablecoins. So it's a very wide range of developers and companies and folks working on Solana. As the sort of head and face of Solana, what has been the secret to cultivating that ecosystem?
I think this is kind of the biggest kind of dramatic change in, I would say, like corporate structure that's been discovered by these decentralized networks that also is like a huge surprise to me. Like Vitalik's not a great businessman, neither am I. We're engineers. Like
Yeah,
he's
yeah,
even like further on the spectrum, let's say, in the research side.
yeah.
Um, and it's really strange that the less control I have, the faster the ecosystem moves because I'm not the bottleneck in decision making.
Mm.
I'm not the bottleneck and even saying what people should be working on or not. Like people are able to participate in the network, make their own decisions, optimize for their own revenue and ROI, and somehow it actually translates into um, some measurable revenue capture for the entire ecosystem. So there is this like flywheel effect of I'm going to build a business in Solana. Great. If you're super successful, you will actually attract more users into the ecosystem that will generate priority fees. And there is actually long-term value capture that can continue driving the whole thing forward. And I'm not in, like, they don't have to talk to me. They don't need my approval. In fact, like, I think I'm wrong more often than I'm right. As every, like, if you've ever tried to build a product and get it to market, 19 out of 20 things fail. Like, if you have like a 5% hit rate, you're an awesome like product developer. So I think this has kind of like I think been the best part of watching this network grow is I get to continue to work on open source stuff that I really love and enjoy, and I'm not blocking anyone.
So on the topic of open source, it was recently discovered that you had this GitHub repo called Percolator, which seems to be the beginnings of a perpetual DEX. So, and this is a hot topic, obviously, because perps were kind of the thing that was behind the October 10th flash liquidation event. Perps are a hot topic in general because of things like Hyperliquid. Obviously, Coinbase has its own perps as well. I actually just wanted to ask you a question, engineer to engineer, is when you build a repo like this, which kind of in prototype phase, like how do you start? Are you vibe coding to start? Are you like, hey Claude, like do you build me something, or like what's your process here?
Oh, like this has been the biggest change with AI is like insane. I used to like open up the eye and code. Um, and now not AI, VI, Vib. So just in case
Yeah, yeah,
people
yeah, yeah, yeah. Of course.
don't know what that is.
Yeah.
Um, and that was when I had time to do that. And like what as the ecosystem grew and just like people pull me into more meetings and I have kids, my ability to code and to churn out code has dramatically dropped. And with AI, it is like accelerated back to effectively where probably I was at my peak. And the cool thing now is I literally never look at any commits. I purely work in between ChatGPT, Grok, and Claude, and I try to analyze the high level design and force Claude to get to the right answer without me having to look at it. And the tools that I found that work well in Rust is that the Rust compiler is great. And now you have formal verification that is really easy to use for Claude, to where I can basically say, okay, this is perps are complicated. There's a lot of stuff that can go wrong. These are the properties that I figured out between Grok and ChatGPT about what I think would work well. Generate a data model, generate the formal verification for it, go verify it, and it'll 90% of my messages to Claude is just continue. Like, it's just, yeah, great. You went this far. You've identified the right problems. Continue. Then every once in a while, where I feel like the big change, and where people may think that this is like kind of a bad sign for software development as a whole, that you're going to have fewer software development jobs. I actually think the opposite. So the reason I'm able to move fast is that I can kind of almost smell the output as like it's going in the right direction or not. So I have all this expertise being an engineer for 10 years. I can just look at Claude in the background while my kids are climbing on me, or if I'm in a call, and be like, okay, it's off the rails, and course correct it. And I think you'll effectively have demand for experts in software, and for any hard problem, you need like a couple people like looking at the output all the time. Um, and this
So
has been true throughout software. Like, you would think that open source would kill the demand for software jobs. No, it only accelerated, because every time you use a open source dependency, you just need somebody smarter at your company to understand what the hell you're importing. Like, that's just the way it is.
So that's, yeah, definitely bullish. Very senior engineers like you. A little questionable what it means for more junior developers who don't quite know what the right architecture should be. But so are you saying like in terms of the code here, like basically a lot of it is just, you gave
I've
it
never
some,
looked at a single commit.
wow, that, that's incredible.
I
Um,
I've basically like asked ChatGPT, okay, I think Claude is lying to me. Give me the formal proofs that it has to verify to where I'm certain that it's right. So I would have ChatGPT design the kind of black box tests that I
mm,
would then have Claude implement and run against.
amazing. I
So don't
did.
use this. There's no audit. I've not looked at a single commit.
don't deploy this to mainnet. I mean, it did have some interesting properties, right? Like I noticed what you call crisis resolution, which I think is essentially ADL, auto deleveraging. So like
Yep,
rather than updating every single account when some ADL happens and deducting, you have some again global state, right? This
yep.
theme that keeps coming over in the Solana ecosystem that is a reference point for all accounts. So it makes ADL much faster.
Yeah, so the constrained environment of smart contracts forces like it's forces creativity. Like, how do you solve these problems where you don't have access to a fast general purpose database like Hyperliquid does? Can you come up with different architecture to solve the same thing? And almost always you can. And I think this is part of the creative the part of the most creative part about coding that I enjoy the most is that working around constraints and finding ways to be equivalent to to a system where you have infinite resources. And a big part of this design actually was inspired by what I saw happen in spot markets on Solana, where in the last, I would say, 6 to 8 months, you had this kind of a ton of creativity in what people are calling prop AMMs. So we had this big debate with Dan Robinson like 4 years ago about AMMs and CLOBs. And basically, where the market landed is that if you have ability to build an AMM that is customized to the particular market maker and liquidity provider, where effectively they have this custom curve that they created. It's not XY equals K. It is their own magical curve with their own messages and Oracle updates. They've effectively created a order book that draws a curve around the liquidity. And instead of having it be a price time curve, they just draw the curve, whatever that curve is, for every price. And they can update it in a single message. That is obviously an improvement over a central limit order book, because you don't have to send 4,000 cancel messages and then updates. Just in terms of like the amount of data that you're transmitting is dramatically smaller. So the fact that you don't have unlimited pipes and you don't have FIFO and like pre-allocated enough resources to guarantee FIFO under load, pre-allocated for that purpose, you're forced to kind of be a bit creative. And I think what this tells me is that like, yeah, you need price time queues give you really nice fine-grained control over every price. But yeah, just draw that curve in a prop AMM and send one message instead of sending 50 cancels, and you get the best of both worlds. And that was really cool to see that innovation happen just totally naturally, just from competition to provide the best price on Solana. Um, so my theory was, can I build basically, I don't want to build a prep exchange because what I want to do is build a data structure so where you can have the same competition. You have a common risk module that can call into Humidify or whatever, Phoenix, whatever comes next in terms of like the innovation on the matching side.
So, is the idea here like you're kind of putting this out in the open, don't deploy it as is, but is it sort of like, is the next step like you want the community to kind of take it, run with it, and see and create something with it?
Yeah, I mean, for me to run like a project, like to run a perpetual exchange and get PMF and onboard users and traders, that's a real thing. That's like a real business. You need a CEO that knows that wants to do all those things to make this thing successful. I'm not that person. What I want to do is code. And like if that person forks this thing and runs with it, that would be great.
Shifting gears a little bit. So, one of the areas of collaboration or organic collaboration between Coinbase and Solana has been the X402 protocol, which is a payments protocol. We recently did an episode of CDPod on that allows agents to accept and pay with stablecoins in a permissionless manner. With the influx of tons of stablecoins and assets coming on chain, seems like a new area that's going to be very hot. And indeed, we've seen that growth on the X402 side. Tell us about your excitement for X402 from the Solana perspective.
I'm excited about it just as an engineer. It kills a there's no point for API keys anymore. Like this is kind of like the biggest, cruftiest part about Web 2 is this like auths and API keys and authentication, and it's just like a gobbledygook of Rube Goldberg machines that people have like clutched together that actually force a lot of centralization. Everyone uses Google Auth because it's the least worst version of that. That means that everyone needs to have a Google account. That means that everyone leaks a ton of their information to Google, and they may be benevolent now, but they're not really. They're profit maximizing. That's good for them. I feel like this is more transformative for the web, honestly, than for crypto itself. Like I think this is probably the coolest thing we could be working on if you were like a 90s web nerd, building those early protocol specs and data structures to define what the web is. Authentication and identity and payments, which payments require all those things, authentication and identity, that was severely missing. And I think had it been able, have we have had enough understanding of Byzantine fault tolerance and cryptography and been able to build those systems in the 90s, I think the web would be a lot more decentralized now. Like you wouldn't have these like major, giant, centralized trillion-dollar companies that kind of own all your data. So I'm it, it's awesome. Like huge kudos to Coinbase for building this. It's like the coolest project out of Coinbase as far as I'm concerned.
That's awesome. Shout out to Eric Reppel, who's usually my co-host here, who's creator of X402. Yeah, I mean, I think X402 derives a lot of its inspiration from, I mean, it's based on HTTP, obviously, and
Yep.
kind of philosophically, we had an opportunity in the 90s and the 2000s to build a bunch of stuff on the base layer of TCP/IP and HTTP. And it seems like now what's happening is we're just building on a new base layer, which is blockchain, which is this decentralized store of value, but also provides these primitives for authentication and identity, as you mentioned, as well as value. Now, a huge part of that story is AI and how that intersects. And we've seen the AI agent narrative come and go. I mean, it's mostly still coming. What's your current outlook on like AI agents coming online and using blockchain as a default method of payment or transfer of value?
Um, if you look at like the best like APIs at a Stripe, PayPal, or whatever, they're 10,000 times more complicated than the first payments thing people built on blockchain, like the Bitcoin node. Like just the amount of cruft that you have to deal with traditional payments is astronomical, relative to the most simplest version, or like the first version of crypto. And I think just engineers will pick crypto simply because of that. They'll pick crypto rails because it just sucks less. And that is actually like I think very important for long-term adoption. Like, there's no way you can kind of stop that train once the ICs, like the end-to-end people that implement stuff, understand the mechanics and how easy it is to work with like open source crypto rails. It's basically inevitable. Um, why it's happening in AI first, I would say, is because um, this is where you don't have entrenched kind of flows already, where every human's on Apple Pay or Android and stuff like that. So adding the crypto layer for payments is going to give you marginal additional revenue because you're already dealing with humans that have a credit card. So you kind of have to be like in the industry to kind of really want to push that forward. But AI is completely greenfield. And it's, you know, there's probably going to be more agents than people at some point or more. So we're going to see that adoption kind of grow pretty quickly.
Couldn't agree with you more. All right, to close us out, two questions we ask all of our guests. First question, so Coinbase Developer Platform, we are aiming to bring the next million developers, billion users on chain by providing APIs and tools that make crypto development easy. From your perspective, what is something that you wish that CDP would build? Could be an API or tool, or something that would help Solana or the broader developer community.
I'm a huge formal verification nerd. I think when you're talking about developers, there's kind of two types of devs. One is they're just going to use existing services on chain that are already deployed. I think there you can basically get Claude to generate all this stuff now. It's just JavaScript and those APIs are really straightforward. The problem with smart contract development, both on Ethereum or Solana anywhere, is that it's just dangerous. Like you build something, there's a subtle bug somewhere that causes, financial loss, and it's scary. So I think getting formal verification is just part of the how developers think when they approach smart contract development that holds value at risk. I think should just be drilled into everyone. And like with Rust and Connie, like it's just been awesome. Like I think we've seen a dramatic shift because of AI. Like formal verification is really hard to do. So now we have AI that can bridge that gap between an experienced dev who sees formal verifications and main pain in the butt because it's just hard math. Having AI bridge that gap, I think, is awesome. So if you guys can help there and get developers to understand when you're building a smart contract, start thinking about it as a math that you need to formally verify and prove. That could be great.
Love it. Proof of work, proof of history, proof of correctness is the next
Yeah.
thing. Awesome. And then last question for you. Who should our next podcast guest be? Any other top on-chain builder or someone you think is doing interesting work who we should hear from?
Oh man. Um, Dunkrad, maybe?
Don't five.
See, yeah, he's awesome. Um, every conversation I've had with him is I've always learned something. I think having him talk about Tempo and Ethereum and kind of that future would be kind of interesting for everyone. Um, yeah, he's one of my favorite people in the industry.
Love it. I think that's a great idea. All right. Well, totally. Thank you so much for joining us today. We learned a lot about how you code and vibe code, the origins of Solana, and how local state and global state interact in all your engineering. And thank you so much for joining us.
Thanks for having me.
Lead the world's transition on chain by building with Coinbase Developer Platform. Visit us at cdp.coinbase.com. Follow us on X at Coinbase Dev, and be sure to leave us a review on your favorite podcast app.